right, we're continuing 8.5 here. We're moving on to Descartes' rule of signs. I do not love my notes for Descartes' rule of signs here, but you do need to know what Descartes is talking about. So what we are doing is we're finding the possible number of positive roots, negative roots, and then we're going to look into imaginary roots. And I find that students that learn this do not learn this right off the bat for the first time. So let's just talk about what we're going to do. To find the number of positive roots, we are going to put in a positive x. So really it's already given with a positive x. Now the thing that I do like about my notes says it's going to be a number or fewer than this by an even integer. And I'm going to come back and explain this to you. But you do need to know that we're going to go by even integers, and hopefully you know what an even number is and an integer is. And then to go ahead and find the number of negative, we're going to put a negative x in. And then we're going to find the imaginary roots by subtracting these. So let's put this into play before we deal with this definition that looks like a lot. So here it says, list the possibilities for the nature of the roots. We need to know the positive roots, the real roots, the negative roots, and the imaginary roots. So I'm going to write this up here. It says p of x is equal to 5x to the fourth minus 3x squared plus 6x minus 10. So if I put a positive x in here, it's already positive, so none of these signs are going to change. I have a positive 5, a negative 3, a positive 6, and a negative 10. And remember, we're working with Descartes' rule of signs. So we're looking at where these signs change. So notice from positive to negative, that's 1 change. Negative to positive is 2 change. Positive to negative is 3 changes. So I know there is going to be 3 or possibly 1 positive root. Now where did I get that or 1? Remember I told you that place I liked my definition where it's going up and down by an even integer? Right there, I liked that. So that's where I got the or 1. I'm just subtracting. So if it's 3, it's 3 or 1. If it's 5, it's 5, 3 or 1. If it's 4, it's 4, 2 or 0. All right, moving on to negative. Now remember when I put in a negative x and I square it, remember I get a positive x. If I have a negative x to an odd power, the sign is going to change. So what that's saying is that I'm replacing all of these with a negative x. So I'm just going to throw those negatives in here. So notice now this 5 times negative x to the fourth power will still be positive. Because the negative 3, negative x to the second power, that's not going to change because that negative x to the second power will still be positive, which makes that negative 3 times a positive still negative. But when I go ahead and look at this one right here, that sign is going to change. Negative 1 times 6 is negative 1. And negative 10. So now how many sign changes do I have? I only have 1 sign change for my negative numbers. So the last thing from here is I can determine my imaginary numbers. Well, earlier we learned that there can be 4 roots. So if I add 3 and 1, I already have my 4 roots. So I know that my first imaginary will be 0. There will be none if there is 3 and 1. Now, what if I have 1 and 1? Those only add up to be 2, so don't I need 2 more to make the second option work? Because they have to total to be 4. We want them to total to be 4. So the number of positive roots will be 3 or 1. The number of negative roots will be 1. The number of imaginary roots will be 0 or 2. And that's how you use Descartes' rule of signs.